Hello and welcome to Calculus tutorial. We are going to take a look at something new, inverses. And then, because this is calculus, inverse derivatives. Now, you might have taken a look at what an inverse was in trig or algebra 2, but if not, I want to do a quick refresher on what an inverse actually is. So, we're going to first take a look at a graphical concept of the inverse, and then I'll show you how to do it again algebraically, and it will probably come back to you. So here I have two graphs. The first one, e to the x. And what an inverse does is it flips that graph over the line y equals x. It just mirror images it on the other side. And in that case, that makes a natural log of x equation. Those two functions undo each other. Now, an interesting thing happens is if you take a look at corresponding points on each graph, we'll take this one. Hopefully those numbers have a bit of a pattern there. Your x value becomes your y value, and your y value becomes your x value. That relationship is what flips this over this line y equals x and makes it a mirror image. And so that is always the case, no matter what. I can't quite get it perfectly on there, can I? Oh well. So no matter where I put these 2 points, you'll see that the x value becomes the y value and the y value becomes the x value. And that's what we're going to use to find the algebraic function for an inverse. So we have f of x is equal to 2x squared minus 8. The inverse, what you do is you switch the x's and the y's. So this is our y value, f is our y, so that will become x. And instead of x, we are going to write y. And then because you always want y by itself, you have to solve for y. So add 8. And then it looks like we're going to divide by 2. And then it looks like we're going to have to square root both sides. So we're left with y is equal to the square root of x plus 8 over 2. And so to put this back into function notation, we would say that the inverse, and we use a little -1 to denote inverse, is equal to the square root of x plus 8 over 2. So that is our inverse function. That's sort of a crash course there. There's a little bit more to it because this should be plus or minus because we took the square root of both sides. This is a parabola. So if you think about a parabola, if I then would to reflect that over that line, it would look something like this. But of course that is not a function, and so the square root only has the top of it, which is why we add the plus and the negative side, which would put that back. But again, that's a little beyond what we're doing here because we are mostly interested in the slope, the derivative. So just remember you switch the x's and the y's and resolve for y. Alright, so this is all about slopes for calculus. So let's talk about the slope of a inverse function. Alright, so the inverse's derivative. What does that look like? Well, let's go back to our visual here. And since we are looking at derivatives, we need the slopes. So I'm going to put the tangent line for each of those points. I don't really need I want the points there. I don't really need their labels anymore. So what is true about the slopes of these two lines? So first, just take a look at how they move. Alright, so when this one is really steep, this one is not. And when that relationship flips, this one is now a very small slope, this one is a very big slope, kind of in general. I can actually put the numbers up there for what the slopes are. Sadly, because they are decimals, it's not very clear what the relationship is. Let's see if I can get us a nice number here. I think 4.06 is the best I can get. There is a relationship here between these two slopes. And what it is this is 4, and this one is 0.25. Hopefully those kind of look familiar. This slope is equal to 1 over 4. So you can see that the slopes are reciprocals of each other. That's a very basic way of looking at it. It's not quite the same because here we are looking at the point where, let's put show label. Here we're looking at the point 1.4, 4.06, and here we're looking at the point 4.06, 1.4. So when you find the pair's point, the slopes are a reciprocal. It's important to note that if you take a look at the point right here at 1.4, right there with the same x value, that slope would not be the reciprocal. So it's a little confusing, but we are going to be taking the reciprocal of the slopes as long as we get the pairs of points straight in our mind. It's a little complicated, but we're still working on it. Where are we here? There. Oops, that's not the one I wanted. I wanted that one. So, the inverses derivative. What you can do, oops, let me go back to this one. If you have a function and you need the inverses derivative, you could just take the inverse and then take the derivative. So here, our inverse was, let's see if I can remember, it was the square root of x plus 8 over 2, wasn't it? And so if you really need the function for the derivative, you can just take the derivative of that. Now this is where it gets a little bit cumbersome to write, because we got to put a prime up here, right? And so what we do is we put that in parentheses, put the prime, and then put the at x. Sorry, there's no better way to do that. This is a 1/2 power, remember, so the 1/2 multiplies down. The inside stays the same. And our power is negative 1/2 times the derivative of the inside. This is just 1/2 x in front, so our derivative there is 1/2. So that would be 1 over 4 square roots of x plus 8 over 2. So if you need the inverses derivative, that's the way you can do it. But you're oftentimes not given a function, okay? So you actually sometimes cannot just take the derivative. So I'm going to give you a bare bones equation or problem where you can see we're not given the function, so we can't just take the inverse and then take the derivative. We have to know the relationship between a function, its inverse, and the function's derivative, and the inverse's derivative. So what is that? So let f be a differentiable function such that f at 3 is 15 and f at 6 is 3. So let's interpret what they just gave us. They just gave us 2 points. All right. So f at 3 is 15. Okay, so that's our first point, 3, 15, and that's our regular function, not our inverse. And they give us another point, 6, comma 3. and that is our regular function f. And then they tell us the derivatives at both of those. So f prime at 3, so m is equal to -8, and over here at 6, m is equal to -2. So we haven't even talked about inverses yet. That's going to come up next. The function g is the inverse of f. All right, so they're just trying to get rid of this nasty nomenclature. They didn't want to have f inverse prime, so they just named this g, and so they could just put g prime. But because this is an inverse, we have to sort of recognize that that is not an x value, that is a y value. Okay, so if I then think about the two inverse points that I know, this is the function. The pair for the inverse would be taking this, making it the x value, which would be way over here at 15, and then going up to 3. So I'll put that in red. That is 15, 3. That is this point's pair. And the other point that we have is the inverse of this, which would be 3, 6, which would be somewhere in there. Oops. And so what do we know? Well, we know that the inverse has the reciprocal slope of the function at its paired point. So this point and this point are paired. If that slope is -8, this one is -1/8 for the slope. And if this one has a slope of -2, then its pair has a slope of -1/2. Now, which one do they want? Well, they want the inverse at 3. So that will be the inverse at 3 right here. And they wanted the derivative of that inverse. So g prime at 3 is equal to -1/2. So sadly, they gave us quite a bit of misinformation. We did not need to know that point or that point. It would have been much easier if they just gave us the one that we needed. The point 6, 3, its pair 3, 6, and then the slopes are reciprocals of each other. If you wanted the formula for that, there is a formula. The inverse's derivative, I'm going to use g just like they use g, is equal to 1 over f prime of g of x. Okay? And so if you were then to look at this, 1 over f prime of g at 3 would be what we would plug in. What is g at 3? G at 3 is 6, so that would be 1 over f prime at 6, which is equal to 1 over f prime at 6 is -2. Kind of hard to work there, but if you want the actual formula for an inverse's derivative, it is right there, where f and g are inverses of each other. But for me, I think just knowing the reciprocal slope and then graphing it, I think this is more intuitive and easier than remembering a formula and where the numbers go. All right, that one's pretty complicated. Thankfully, it's kind of a small subject for us, but it is something I would like you to see. Come talk to me if you have questions still.